So here we are in the final module of the course where we're talking about principles of living systems and how it's biomimicry in some sense. We can take the principles that we see in living systems and learn to use them to develop in the development of sustainable systems. So we're just going to look at some of these. I've taken it from Linda Booth Sweeney's list of principles of living systems, but there are actually many others out there. So this is not the only one. They're not exhaustive. It's just to illustrate how there is a lot of thinking around living systems theory, and we can borrow and use that to inform sustainability in practice. So here we are, there's 12 of them. The first one, let's take a look. Interdependence, a relationship in which each part affects and often needs the other part. Interdependence is really a core idea of systems thinking. Yeah, we definitely see it out there in the world in terms of ecosystems. Systems integrity, what a system has when all the parts and properties essential to its ability to function are present. So we talked a lot about that in the beginning, earlier sections. We talked about holism. We divide something up, it loses its integrity and it dies. So those are two: interdependence, integrity, biodiversity, the variety, complexity, and abundance of species that, if adequate, may make ecosystems healthy and resilient. So the concept of the importance of diversity within a system for resilience and other factors, for creating those synergies. Also, we talked about that. So cooperation and partnerships, the continual process in which species exchange energy and natural resources. So it's co-creation and synergies. Rightness of size, the proportions of living systems, their bigness or smallness, and their built-in limitations to growth that influence the system's stability and sustainability. When one aspect becomes overgrown because there's a broken feedback loop, it can become unsustainable. We might see that with human systems or in other ecosystems. Living cycles. A cycle is a circular process that repeats over and over, frequently returning to where it began. Water, lunar, sleep, and other cycles sustain life, circulate resources, and provide opportunities for renewal. Waste equals food. When waste from one system becomes food for another, all materials in nature are valuable, continuously circulating in closed loops of production, cycle, and reuse in a synergistic way. Feedback loops, circular processes that create growth or decay by amplifying change, reinforcing feedback, or foster stability by countering or lessening change. So most, or if not all, ecosystems, living systems are maintained in a stable equilibrium and sustainable fashion through feedback loops. And when they become broken, things become unsustainable. Emergent properties, behavior that arises out of the interaction within a specific set of parts, the health of an ecosystem or a team's performance, for example, are emergent features. Flux, the continuous movement of energy, matter, and information that moves through living systems. Flux enables the living or open systems to remain alive, flexible, and ever-changing. The sun, for instance, provides a constant flux or flow of energy and resources that feeds all living organisms. So kind of, yeah, back to the idea of dynamic, process-orientated view of the world. And the last one, the commons, shared resources such as air, water, land, highways, fisheries, energy, and minerals on which we depend and for which we are all responsible. So that was just to give you a quick insight into how the principles we've learned about living systems can be applied in the context of understanding what sustainable systems would look like, all the fundamental principles for designing and developing those.